In this nugget, we'll be discussing DHCP. This is actually a fairly simple nugget in terms of the list of items that we will be addressing, so I didn't even put them over here on the right-hand side. You'll see all those in the next whiteboard as it comes up. However, in addition to what we'll cover there, and in addition to what's in the exam objectives, I'm also going to cover some extra material that might be very useful for someone who ever has to administer DHCP. A few years back, I went to Glacier National Park in Montana with some friends of mine. We were really looking forward to seeing some wildlife, and in fact, later on, I was able to shoot some photographs of bears. Actually, one got a little too close for comfort, but that's a story for another day. But on our first day there, we saw our first sighting of wildlife. Yes, it was mountain goats, and here I took a photograph of a mother and her child. Or I guess they're called kids when they're goat babies. That's the goat language term that you use. Anyway, so we were really excited about this, and then as the week went on, we saw that there were a bazillion of these mountain goats. There were so many of them out there. They were very abundant in numbers. Well, you know, when it comes to things like IP numbering, you have to determine how many numbers you've got, how many you've got to dole out, and you also have to determine if your scope is big enough. Now, we looked at in a previous nugget, IP version 4, for example, at how to custom subnet or how to supernet if you want to play with the numbers in an IP configuration that you've been given, a network ID. We also saw in IP version 6 that it's really not necessary to mess with it that much because your clients will self-configure an IP address based upon, well, maybe an ISOTAP router or based on some other router that is advertising a route. And if we follow the formula for IP version 6 at least, we probably don't even need to use DHCP to issue IP addresses. Now, IP addresses can be issued for IP version 6 in DHCP, but we don't really need to. And you may also have various options that you want to dole out as well that your routers will not issue, such as DNS servers or any other kind of configuration information. So we'll take a look here at DHCP services, how to install a DHCP server, and all the other options you see here, which basically covers all of the exam objectives. So as we've kind of seen a little bit in the past, we're going to use DHCP services here to automatically configure our IP addresses. Now, what we have to do first is to install a DHCP server, and then we'll be able to create and configure the scope. So let's go ahead and do that just by way of practical demonstration here. I've gone to a server that I've named DHCP01, and I'm going to go here to Manage and Add Roles and Features. Okay. Having done that, we'll just go through the wizard. It's very, very simple. Not really a whole lot to be concerned about here. So I'm going to quickly go through this because you've seen a lot of this kind of thing before. But as we go through it, we're going to just select DHCP server, and then we'll just add any features we need, such as the tools that we need to manage a DHCP server as we click on Next. And then I don't need anything else in the next page, so I'm just ready to click on Next and then Install. And that's pretty much going to be it. You don't have to restart the server, so I'm not going to select that last box to restart the server. And once this is completed, then we'll need to configure a scope so that it actually has one or more IP addresses to give out, hopefully more than one. And then when that installation is finished, then all I have to do is to go to Tools and then DHCP. Very often I'll be doing this from a Windows 7 or Windows 8 machine with the remote server administration tools installed. Here it puts the focus right on the server. If not, you can right-click here to choose Add Server. And very often we'll add multiple servers here because you'll have many DHCP servers you're trying to work with. Anyway, as I go up to this, I can expand down, and you can see that for both IP version 4 and IP version 6, that just gives us kind of a red arrow there. I don't know if you can see that or not, but there's a little red arrow that's telling us that there's nothing configured yet. In other words, yeah, it's a DHCP server, it's just not doing anything. So I'm going to have to give it some work to do. Now, let me start with IP version 6, because this is pretty brief, and there's really not a lot to worry about here. And that's because, again, normally we have our clients auto-configurating themselves on the basis of a router advertisement. So we saw that in the last nugget. However, we may have some server options such as a DNS server. They might need a DNS server. So I might say, well, we need to specify the DNS server since the router advertisement doesn't do anything to help us with that. Without checking this, my clients would get an IP address configured automatically, but they would not get a DNS server without an option here for me to select. So I'm going to choose a DNS server address. I'm just making one up here. 2001::1234, and then I would click on Add. Now, when you do that, it does check to make sure that that DNS server actually does exist. If it does not exist, it'll give you a message, and you can still add it in if you want to, but you wouldn't do that unless you knew it didn't exist now, but you planned to bring up that DNS server very shortly, and you knew that it was going to be available just any time there. Otherwise, we'll go up here to IP version 4. Now, here's where I want to go ahead and configure my scope. Now, you'll see that initially there's nothing here relating to scope, so you have to right-click on IP version 4, and then you choose New Scope. Okay, so having done that, it just takes you through a very simple wizard. Now, I'm on a 10.10.10.network, so I'm just going to call this my Nugget Lab 10.network. 10 network, something like that. Okay, it's a little bit arbitrary. You don't have to name it anything specifically as long as it's clear to you. You can enter it into a description if you like as well. Now, here's something else you might want to be careful of. You see, on my network, I have several IP printers. I have some servers with static addresses and so on, and all of those start down in the 10.10.10.1 up through 10.10.10.30 IP address range. Now, I could include that entire scope here and then simply do other tricks, such as making exclusions or reservations for something in that range that I want to have the same address all the time. We'll talk more about that here as we go along. But another thing to do is, if I already know that I never want to issue those addresses, I'll just start at a higher level. So 10.10.10.30 through 10.10.10.254. Okay. Remember, we can't go up to 255 because that would be a broadcast address. And then we want a 24-bit subnet mask. In this case, you can make it whatever makes sense for your network, but I'm only going to use a 24-bit subnet mask. Then here's where we could add exclusions. So, for example, maybe all of that range from .1 up through 30, or through 29, I guess, actually. There are many servers there that already have those IP addresses, many printers. But maybe beyond 30, there's only one. Just that I don't want to exclude the whole range. So I would say that 10.10.10.30 here through 10.10.10.32, well, there's a couple of other servers, 2 or 3 other servers that I've got going on here that I also don't want to have addresses issued to in my clients. So click on Add there. Now, we will never issue these addresses, anything in the range that I've specified. You may have also seen this down here in the lower right. What in the world? Subnet delay in millisecond. First of all, I think that's supposed to be one word, but anyway, so why would I put a delay in there? Why would I put 10 milliseconds or something like that? It just seems like it would make things take longer, and doesn't Windows take long enough as it is already? Well, the reason why we would do that is because sometimes you might have more than one DHCP server around, and you might want to prefer one DHCP server over another one. Now, there's other ways of doing that, especially when it comes to redundancies, which I'll talk to you about later on. But if I had two of servers up there, 2 DHCP servers, and the other DHCP server was my preferred one, then I might put a delay in on this DHCP server that we're looking at. That way, the other DHCP server will automatically give out most of the addresses because it'll be able to respond faster than this one will. But I'm not going to use any delay here. Then we'll click on Next, and we specify how long we want these leases to last. You can see that by default, it's kind of a small text there, so I'll just zoom in here. You can see that by default, it's 8 days, and that's usually fine for any kind of general use. Mostly what we do here is the fewer addresses we have, like let's say we only have a handful of addresses above what we think we're going to need, then if you're pretty tight on addresses, you normally make this shorter. That way people that go off the network are not using an IP address in the DHCP database that could actually be used by some other client, especially since that computer's turned off or gone. This is even more true on something like a wireless network. However, some people also would say if you have an abundance of IP addresses, maybe I've only got 10 hosts on this network and I've got 256 or 254 possible addresses, well, then I might make that extremely long. I might make it 30 days or something like that, especially if I want to usually have a pretty reliably the same IP address for my different clients. So it's a little bit arbitrary once again. I'm actually going to do kind of a weird thing here. I'm going to make that 0 days and change this to 2 minutes. Now, I'm only doing this for demonstration purposes because I'm going to need to forcibly allow some of my IP addresses to expire in the future here so that I can show you how certain things such as failover will work. So then we'll just click on next, and we also have some DHCP options. This again would be things such as the default gateway, the DNS server. Those are the two most common things that you'll configure. Many of the other ones, there's a bunch of them there. Many of the other ones are kind of esoteric, and I don't even know if anybody's ever used some of those different options. But I'm going to say, for example, here, what my default gateway is. That's going to be 10.10.10.1 on my network, so I'm going to enter that in here. Click on next. Usually, a default gateway is very often either the first IP address in the range or the last one. Okay, in my case, it's the first one. And then the parent domain for my DNS servers. What does this mean? Well, this means that when someone at the client maybe pings a server, like they're ping server 1. Well, if they just enter in that much, that's a flat name, and it's not really the fully qualified domain name of server1.nuggetlab.com. So what will happen is if they type in just a flat name, it'll automatically default now with this parent domain information to nuggetlab.com. So it would be the same as if they typed in the fully qualified domain name. Now here I could enter in the IP address for my servers. So I could enter in a server name right here. Let's say DC Nugget 01, and I could resolve that and say, oh, that's .70, thank you. And then I could add that in here, or I could just enter in the static address itself here. You don't have to put in the name. You just do that usually if you need to resolve it. I've actually got two DNS servers here already that I'm pretty good with. That's my DNS server for Active Directory, and this is one that I use for a lot of internet resolution. So I'm going to click on next. Again, somewhat arbitrary. You just do whatever your needs are in your organization. Here I don't have any Win servers. They're really phasing out in a lot of networks, but it's used for NetBIOS flat name resolution. I'm going to click that off. And then you can also activate the scope. Now, you might have heard of activation. There's a couple of different kinds. Number one, you can activate the server in Active Directory so that it's authorized. Actually, it's authorizing the server to issue IP addresses. But even if it's authorized properly, unless I activate the scope as well, then it will still not dole out any IP addresses. So I'm going to choose Activate the Scope now. Right now, the server itself, however, is still not authorized. Well, so what's authorization about? Well, it used to be that people would try to experiment with DHCP. IT persons, they would say, hey, I need to bring up a DHCP server because we're going to put one in the lab, or I'm thinking about setting one up here or there. So they'll just kind of experiment, and they'll set up a DHCP server, they'll configure a scope, and then it'll start issuing IP addresses, except that it might not be what we need for the network that it's currently on. So, for example, here I set up a 10.10.10 network, but maybe we're actually on a 192.168 network. Now, if I'm just playing around and say, hey, I want to set this up because I'm probably going to move it into a lab next week or something like that, and if I were to then activate everything and then authorize this DHCP server, now it's going to start issuing these IP addresses on the wrong subnet. That causes huge disruption problems for your clients, because then all of a sudden they can't connect anything. The help desk phone is ringing off the hook, and it gets to be a real big problem. So what Microsoft did is they said, well, let's put a speed bump in here. Now, it will not cure all ills, because people will still authorize servers they're not supposed to, but it's kind of a gut check, and they say, hey, are you sure you want to do this? I mean, this is you already got a scope here, you've already activated it, everything's good there, but do you really want this to be in production? Because if you do, you're going to have to right click on this and choose authorize. Oh, you do? Okay, good. Well, then go ahead and click authorize then, and now you've got a legit DHCP server that's ready to provide service for DHCP. Now, obviously, this, again, it does not cure all ills, because there are other DHCP servers out there that are not Microsoft-based. It could be, for example, maybe someone brings into the office one of those Linksys or Netgear routers that are the wireless routers. Maybe they just want to set that up in the conference room so no one has to plug into the wall jacks. Well, now that's usually going to also be a DHCP server that's going to issue IP addresses, and that's normally what they do by default. So that kind of thing happens all over the place. Someone might set up a Linux DHCP server. Someone might even set up a standalone DHCP server. By the way, even if it's a current Windows server that's a DHCP server, if it's not a member of a domain, like this one is right here, then it can actually issue addresses without being authorized. However, once it detects an authorized DHCP server on the network, it will stop issuing addresses. It kind of acquiesces to the authorized one. Now, having refreshed the screen, we see that this becomes a green arrow, so we can see that everything's working out okay. Let's see what we've got here, if anybody's leased anything from us yet. To do that, we would go down to Scope and expand that. And then here's our address pool, which identifies the exclusion, which we got down here at the bottom, and then the actually available addresses that we have up here at the top. And then here's the address leases. Okay, it looks like somebody's leased a somebody's leased an IP address from me, somebody's iPhone apparently, in my small little network, and then whatever that device is right there. So let's take a look at what we've addressed so far. We took a look at creating and configuring scopes after installing DHCP. We also took a look here at authorizing a DHCP server. Now, let's move on here to reservations. And what is a reservation? This might be useful if I have, let's say, a server or some other important client computer or something like that, that I always want to have the same IP address, but I do not want to configure static IP information. So where we would manually enter in not only the IP address, but also manually enter in a static DNS server, default gateway, any of those other types of options. It could be that I want it to always have the same IP address, but what if my default gateway changes? What if my DNS server changes? Well, with a statically configured setup like that, all of that stuff would stay the same, and then all of a sudden I wouldn't be getting service on that machine, and I'd have to go back in and statically change all of those things to whatever the new settings were for my default gateway or DNS server. Now, with a reservation, however, what I can do is to go into this thing, and I can say, hey, you know what? I want this thing here to always get this IP address, and I'd have to know its unique ID. In other words, its MAC address. I can actually also just write it down if I want to, or now this is something that's current in newer versions of DHCP here from Microsoft. I can right-click on this thing and just click Add to Reservation, and now it's successfully added that to a reservation. So whatever this device is, I guess I should find out what that is. Whatever that device is, with this MAC address, anytime it comes on the network and it gets an IP address from this DHCP server, it will always get 10.10.10.37, and it will also get changed DNS servers, changed default gateways, any of those other kinds of options. And if I go down here to reservations themselves down here, we can see that it's inheriting its DNS domain name, its DNS server, and the router configuration. And so this kind of gives me the best of both worlds. I get all the benefits of DHCP and automatically updating any of these things if they change, and at the same time, I get the advantage of a static IP address because it's always going to get 10.10.10.37 on this particular MAC address. Also notice that these values here for each one of these options are the exact same thing that we have when I first configured my scope options in the wizard. And that's because it will inherit in a reservation, it'll inherit whatever my scope options are in that reservation. Now if I want to override that, I can. So for example, maybe this particular IP address uses a different router. I want it to use a different router. I could go to properties, but that doesn't give me anything because look, it just gives me some message. So what I'll do instead here is I'll go to the reservation over here, right click on it and choose configure options, and then I can statically configure a different router IP address. Let's just say it's 10.10.10.254 or something like that. Click on add, click OK, and now you can see here that it's going to, when I refresh the screen, got a different value there, and it's no longer inherited, and it uses that little, I don't know why they do that, but a computer screen icon. I don't know how that communicates that that's a manually entered in value, but there you have it. And so then returning to our little whiteboard here, we just took a look at the options. And again, you can configure that in the wizard when you first set up a scope, or you can go back in afterwards to edit them, whether it's for a reservation or whether it's the options for the entire scope itself. Also, let's take a look at here at this, something called Client and Server Pixie Boot Configuration. What's that about? Well, Pixie, or PXE, means pre-boot execution environment. Very often, especially in a deployment scenario, then you may have a computer that's just bare metal. There's nothing on the hard drive, so it has no operating system to boot. And you're not going to take a DVD or a CD around with you to install the operating system on every machine. Instead, what you could do is you could set up what's called a Windows Deployment Server, or a WDS server, in your environment. Let's just do this. Here's my WDS server, WDS, and it's on the network here. And then here, I have a client. And I'm just going to make this look like an old 1980s IBM PC desktop computer. And this is the client with no operating system on it. Well, when it first boots up, it needs to contact a DHCP server if it wants to be able to download an operating system from my Windows deployment server. WDS server can be configured to have many different operating systems from many different versions of Windows. Server operating systems, client operating systems. You can set up Windows XP up there. You can set up, not that I've seen that very often, you can set up Windows Vista, Windows Server 2008, 2012, 2003, whatever you want. Anyway, so since I don't have an OS here, when it boots up, it needs to get an IP address from this DHCP server, and then once it's on the network, then it can contact my WDS server. Now the key here is that when this client here initially broadcasts for a DHCP server, it does so over UDP port 67. And there's actually a whole process that goes on in that's important to know. I don't know that it's directly on the exam, but in terms of general networking, you should know this anyway. What happens here is when it initially broadcasts over UDP 67 looking for a DHCP server, that's called a discovery packet. Okay? And that's just saying, hey, I don't have an IP address. I'd sure like to have one. Are there any DHCP servers out there? DHCP servers have UDP port 67 open and listening, so it'll say, hey, I've got a scope of IP addresses and options ready to go. I've got a smoking deal for you, so I'm going to offer you something that you can't refuse. And it'll give its IP configuration to that client. Then the client says, hey, that looks good. I'm going to request to keep that information, and it'll send that back to the DHCP server so that it can then register in its database that that IP address is being used, and that way it doesn't double issue it to maybe another client that also needs an IP address. Also serves another purpose. You may have multiple DHCP servers on the network, and they may all be sending out offers to the client that sent out that initial discovery packet. Well, those other DHCP servers need to know that. Well, they didn't get picked. Okay, so when the client sends back the request, it also is heard by the other DHCP servers, and they say, oh, I guess you didn't pick my IP address. Then they all hang their heads in shame. And then the server here will send back to the client an acknowledgement that it can keep that configuration. Now that's how things all work, and that's just fine. The thing that happens next, however, is this client here says, hey, I'm feeling kind of vulnerable. I have no operating system whatsoever. And so it says, I would sure love to find a WDS server. And what it'll do now is it'll broadcast again for a WDS server. And this time again, it uses UDP port 67. And that's fine. The WDS server will respond, and then a TFTP transfer occurs, and some other things happen until eventually it gets an operating system on that client. Now that's all well and good, but actually there's some things that can go wrong with this. Not in the situation I just showed you, but in this kind of a situation. What if we only had a DHCP server, and then someone said, you know what, I'm so tired of dragging a DVD all over the office building and installing everywhere. I think I'd rather install this thing that I heard about called a WDS server on our DHCP server. And that's fine. But what will happen now is, anytime a service is using a port, it can't be double used by two or more services. Only one can use it. So that would mean that once we get our IP address from DHCP, when we send out another packet looking for a WDS server in a Pixie boot, well, it'll be blind to that WDS server because it'll be blocked from using UDP port 67 since it's already in use. So what happens instead is, and this is handy, it's almost automatic, is that when you install WDS here, there will be a page here, and I'll show you that shortly, that says, hey, you're already a DHCP server, so we can't use UDP 67. Would you rather use UDP 60? And there's actually an option for that, and what will happen is it'll point to the WDS server on a different port number. Now we're able to use the same server for both DHCP and WDS. So by way of example here, I just went ahead and added in WDS here, and I was just going to go ahead and configure it. This is something that's not on the exam. They don't really cover WDS per se, but I'm just going to show you in this case how I would configure it up to this point as it relates to DHCP. Here we just get some introductory information. It says that we do need Active Directory, a DHCP server, DNS, and an NTFS file system. Those are some prerequisites, pretty simple. And then we can say we want it to be integrated with Active Directory or standalone. I usually make mine integrated. And then we have to have storage space to install WDS files. This would be things such as images and the like. Usually you put it on a different folder or a different drive, but in this case I'm going to keep it on the same one just for simplicity's sake. And this is the key page that we're really interested in. We're telling WDS to not listen on DHCP and DHCP version 6 ports. In other words, don't listen on 67. Okay, and then it says configure DHCP options for proxy DHCP, and that's another thing that relates to port 60 that I was talking to you about earlier. Okay, I'm just going to go ahead and quickly finish the wizard, just so we can get through it, so we can see some of the items here related to DHCP. As I go back into the scope options here when it's done here in the background, we'll see some of the changes that were made. Okay, so the wizard went ahead and finished, and I refreshed the screen, and we see that it's kind of getting going here. So we got a WDS server going. Now here, I'm trying to find my, where was it? My server option, I think it was. I'm trying to find the option there that was 60, right? Didn't I mention something about 60? But I don't see it here, and if I right-click on it to choose configure options, let's see, if I scroll on down, this is kind of weird. I don't see port 60 involved in this, or that is an option. It's not port 60, it's option 60. So where did that go? This is one of those kind of weird things. If you had the DHCP console open at the time you did all of this, you have to not only refresh the screen, which I just did, and it just gives me unknown. You actually have to close it and then open it up again. Okay, it's just a weird kind of strange thing that I don't know if it's in the console thing or whatever goes on with it, but for some reason that's what you have to do. Okay, so then I'll go back down here again to my IP version 4 options here, and then I'll go into my server options. Now we see it has appeared. Now let's take a look here at the DHCP relay agent, and as you can see here, I've kind of revised my drawing over on the left. I was very careful, by the way, I hope you noticed this. I was very careful to preserve my original IBM PC computer down here, because kind of proud of that artwork. Yeah, that was hand-drawn, people. Anyway, when I got this client here, in our original diagram, it did the discovery, offer, request, acknowledgement, and everything with a DHCP server that was on its same subnet. Well, all of this stuff right here, it's broadcasts. Guess what? If I have a DHCP server on a different subnet, it's going to be separated by a router. In this case, it might be a Windows Server 2012 router. It could also be a hardware router. But regardless, routers do not normally forward broadcasts. That's part of the reason why they're there, is so that they can cut down on all the chattiness that takes place on these networks. So now what's going to happen is, if we're using automatic configuration for the IP configuration on this client, it's going to broadcast, and it's never going to get an answer, and then it's going to get the dreaded 169.254 address, and it'll really not get much accomplished. So what we have here is something called a DHCP relay agent. This is actually another method for being able to forward our broadcasts across the router to the DHCP server. You can also use a hardware solution here using a router that is capable of something called boot P. And they're both really basically perform the same function. In this case, if this is a 2012, or actually any current version of Windows Server, I just have to make this a DHCP relay agent. Okay, and let me show you how I would do that. Here I would go over to, for example, this machine. And I just already installed routing and remote access. You do have to have that installed in order to install DHCP relay agent. But you just go down to IP version 4, you right click, and then you choose new routing protocol, and you say, I want this to be a DHCP relay agent, and now, bam, there it is. All this means is that once I properly configure this, it's going to have the IP address of a DHCP server. So I right click on it to choose properties, and I say, hey, my DHCP server is at 10.10.10.71. So anytime you hear on an interface, anytime you hear a broadcast for a DHCP server, then forward it to 10.10.10.71 as I configured there in the properties. That's it. Pretty simple. Alright, here I'm going to take this thing into extra innings, which I call it that because this stuff here isn't really part of the exam objectives, but it's pretty important for the administrator to know how to do this stuff, and it could really be important, especially in the event of some kind of a failure. So let's take a look at a couple of these. First of all is the DHCP database. Now, if you already know how to work with a database in DHCP from previous versions of Windows Server, nothing really new here. It's really pretty much done the same way. But you need to know how to back it up, because then you may need to restore it someday. The key there being, maybe I've got a DHCP server which the hard drive failed. And so now I need to replace it, and maybe I re-imaged Windows Server on there and everything. But it didn't really have a current copy of the DHCP services and the database and all of that. Well, if I've got a backup, I can just install the DHCP service, really on any server, and then restore the database, and it's back up almost instantly. It's very, very effective. Also, DHCP as a service, it's really a pretty good and reliable service. It's not one of those things that all the administrators hate, and it's like the service has big red horns on it and nobody likes it, something like that. Usually does its job pretty well. It's usually when a hardware failure or an infrastructure change takes place that we have to work with that database. Also, there's something called reconciling the database. There is some information that is also duplicated in the registry, and so you need to sometimes synchronize what's in the registry with what's in the database, especially after a restore. It's a good idea to reconcile the two. Let's go ahead and take a look at how we can work with this. Now, first of all, as I go into this, I want to just add one other item. I wanted to point out these filters items to you. This is actually extra innings, because I wasn't really a part of our exam objectives either, but I'll talk to you about it. One of those would be I could use these for allow or deny. Now, if I go to allow and I choose new filter, what I have to do is to enter in somebody's MAC address. I'm just going to bash in a bunch of numbers here, but just bash in somebody's MAC address. You probably copied and pasted it from something, and then you can enter in a description if you want. Now, here's the thing: you got to be careful of this one. Because now, from this point forward, whoever has this MAC address, whatever that belongs to, a computer or an iPhone or something, that's the only device that's ever going to get an IP address from this DHCP server. So it's an explicit allow. It's strictly a whitelist. Okay. However, this is a blacklist, meaning that anybody I add into the deny will not be able to get an IP address. Now, let's go ahead and up and take a look at my leases. This makes it a little bit easier as well. Sometimes when you work with Wi-Fi that's possibly just a little bit too easy to get into, you might have interlopers here that are getting IP addresses that you don't really want them to have. For example, here's my iPad. And let's just say that as company policy, we're not allowing people to bring iPads to work anymore because they just wind up playing Angry Birds all day. So what I could do is to deny that. Now, I'm trying to memorize this list. 442A6. I forgot it already. I can't even memorize that unique ID or that MAC address to create a deny. So one thing that Microsoft has really nicely done is they've given us the ability to right click on it and choose deny. So now my iPad will not get this IP address anymore, and we can see down here that it's now part of the deny. I also want to point out something else to you here, and you have to be careful of this. I could choose deny new filter, and I could go according to manufacturer. So maybe it's B, C, star. Every MAC address is really, the first few characters there are really the manufacturer's identification. So I don't know who BC is, but let's just say it's BC star, and if I just click on add, I'll just type in, test for the time being. I click on add and close. That means that any MAC addresses that start with BC will in a blanket fashion, never get an IP address from this DHCP server. Now I'm going to delete that for the time being, because I don't want to lock out something I really need to have an address. The other thing to keep in mind there, though, is, and this is something that people have an erroneous conception about, they have the feeling that for example, all iPhones start with the same MAC address. They do not. Apple gets their network interfaces from different manufacturers, different batches, all that stuff can change from time to time. So you'll notice that all of these iPhones, even my iPad, they all have different prefixes on their MAC address. And so don't just go by that alone. You have to study that out and make sure that you've got the right manufacturer, and make sure that it's even possible to do this in the way that you want to. Now then, getting back to our database, now we have some more stuff. We've got several leases here. We've got some deny stuff. We've got some server options, our Pixie thing here. We've got scope options. I don't want to have to recreate the wheel for all of that stuff, particularly this. This is a big problem, people. All the other stuff I had to manually configure, but here, if I were to down this DHCP server for whatever reason, I had to bring up another one. I could recreate my scope and all of that. It's a little bit of a hassle. But what's going to wind up happening is that all of these addresses in this range are going to start being duplicated. As you see, these hosts right here already have these addresses. Now, the replacement DHCP server with the same scope, it's going to start to overlap these addresses, and I'm going to get duplicate addresses on the network. Some people have erroneously said that, no, James, you don't have to worry about that because DHCP automatically pings any address it's about to dole out. That is incorrect. Let me show you how I know about that. Let's go up here to the server where it says IP version 4 right here. So I'll right-click on IP version 4 and go to Properties. And if we go to the Advanced tab, look what it says here. Conflict detection attempts, 0. You see, if I were concerned about that, and I thought, oh, we had a problem with our DHCP database, and I think the DHCP server is accidentally doling out duplicate addresses, then I would manually go in here and enter in 1 or 2 or something like that. 1 is usually plenty. And if it gets a reply back now, then it won't issue that, 10.10.10.33 or 34, any of those, because it'll say, hey, somebody has already got that. But otherwise, you have to be careful, because just recreating the DHCP server from scratch, it's going to start issuing duplicate addresses. It has nothing in place to prevent that from happening. IP version 6 you don't have to worry about, because it has duplicate address detection already built in. The other problem I've heard is that people have said, well, if you back up the entire DHCP database here, and I'll show you how to do that. I'm getting there. Don't worry, I'll get there. If you back it up, it only backs up the scope and your scope options and server options in this list down here, and that sort of thing. It doesn't actually back up the leases themselves. That's incorrect as well. It actually does back up the leases. That's part of the whole reason why you want this backup. Because especially in a simple environment, I can recreate this other stuff without too much effort, maybe in a couple of minutes. But the leases here is a big thing, and of course this is a short list. A lot of organizations will have hundreds of leases that are doled out here that you don't want to have duplicated. When I properly restore that list through a restoring of the backup, then it will automatically put the addresses in the address leases node that we see right here, and it will not attempt to reissue any of those. The only difficulty you could run into is, let's say I didn't really have a current backup of my DHCP database. These are a month old or something, and my lease duration is 8 days. Well, in that case, this doesn't do me much good. But if I am going to do a graceful shutdown of a DHCP server, I know I'm going to decommission it in advance. Maybe the hardware is too old, it just can't keep up anymore, or something like that. I'll create a backup right away. Then I'll down it. I'll bring up my another DHCP server, and I'll restore the database immediately. And then I'm going to have very little problems with an overlap here. Let's talk about how to back up this whole thing. If I right-click here, first of all, and go to Properties, you'll see the database path. There's not really much reason to change that. Sometimes Microsoft would recommend putting a database on a different hard drive. The DHCP database is not as intense as something like a full-on SQL database that a company depends on or something like that. So this is not really quite as sensitive as that. You can leave it there if you want to. The backup you probably ought to put somewhere else. I'm leaving it here just for demonstration purposes. But the whole point of this is I want a backup. And if my hard drive fails, well, my backup's on the same hard drive that failed in this case, so that would be a problem. So just be aware of that and find a judicious place to store that backup. So let's go ahead and back up. So I'll just right-click here and just choose Backup. It's just as simple as can be. It shows you the folder here by default. You can go to a new one or a different one if you want to. Let's go ahead and choose the one that we've got there. Then I'll click OK. All right. Now I just backed up my database. And then cutting ahead real quick here, I just went to Windows System 32 DHCP and Backup, and there you can see is all my backup. Now I'm going to take that to another DHCP server and quickly restore it, and we'll see how easy that is. And now then here I'm gone to another server. This one's dhcp02.nugalab.com. You can see I just installed DHCP over there. And I disabled the service over on DHCP01 to simulate that it, caught on fire or something like that. So now that DHCP has been installed over on this server, this would be an ideal situation where I'd want to work with that backup. It's a fresh backup. And, there could be something that gets leased out in the meantime, but it should still be all right, especially if I turn on conflict detection attempts. But that's all right. I'm just going to right-click here and choose Restore. Then I just copied it all to a different directory on the hard drive here. I think I just called it DHCP Restore or something like that. DHCP Backup, that's it. Click OK. It's got to change some permissions on the file because the file system is different than the source. But then it says the service has to be restarted. That's fine. It's not doing anything right now anyway. So then I restart it. And then here in a moment, we're going to go ahead and take a look and make sure that it restored everything that we wanted. Then we would have to make sure that it was able to actually issue any new addresses if we wanted to. But anyway, so there we got it going. You can see here that we've got our scope. There's our address pool. Okay, we got our exclusions. We have our scope options. Nothing's changed there. We've still got our server options, Pixie client. We got our filters. We had our deny in there. Oh, I got to take that out before before my iPad stops working properly. I'll panic if I can't play Angry Birds. Anyway, so then we'll go on to our leases. Remember I told you earlier it does back up the leases. There they all right there. So it will not attempt to reissue these to any other clients that are asking for IP addresses. So it looks like we're pretty up and running here. The other thing I would need to do actually is to authorize this, wouldn't I? So I'd right-click here and choose Authorize. And then in a moment, we'll see the red arrow go away if I refresh the screen. And we'll see, there we go, sure. Now we've got an active scope working, and if you're not talking and jabbering on like I am, it would probably take less time than what we just watched here, especially if you know what you're doing. So, very effective way to back up and restore. One other thing I almost forgot. Also, you need to reconcile this. It's just a good practice after restoring, especially if you restore the database to the same server. So, for example, maybe the server was working fine all along. It's just that we think that the database might have gotten corrupted or something, or is acting kind of weird. So we just take a database backup that we'd made that we know is good, then we restored it, and then now we would right-click here, and then we would choose Reconcile, and then we would just verify everything. The database is consistent, and we're good. That's it. Now let's move on to the final topic here in our extra innings, and that would be something called DHCP failover. Here let's take a look at an example of what we've done in the past. We might have two DHCP servers separated by a DHCP relay agent, which I've got here in the middle. And what we would have here is, I might have this DHCP server issuing 70% of its subnet's addresses, so this is 10.9.8.0 on this side of the router. And then on this side of the router, we have 10.9.8.0 on this subnet over here. So what we've done is we've decided to share the load, and we'll say, hey, I'll be your best friend if you'll be my best friend, and we'll share each other's scopes. So I'm just going to use 70%. I'm going to configure a scope that only has 70% of the address space for this subnet ID. And it doesn't have to be 70%. It's kind of arbitrary, but it could be 80%, whatever you want. Anyway, I expect this DHCP server to issue the addresses most of the time, therefore I'm giving it the majority of the addresses, and it's probably going to hold true that it will, because even though this DHCP server will hear the broadcast because of the relay agent, it's going to be slower just because of this little hop right here, and therefore this server over here will probably issue most of them anyway. Okay, so anyway, this is called a split scope arrangement, and then we reciprocate that on the other side by choosing to do 198.168.1.0, 30% over here, and over here where the actual subnet is, this DHCP server does 70%. Now, if this server fails, then this server will be able to still provide service not only to its own subnet, but also to this subnet because of the relay agent. The other method that we could use is instead of doing something like this where we have the split scopes, let me just kind of clean up a little bit here. Use my handy little eraser, is we might have just actual clustering involved instead. So in this case, they would have a shared database. Okay, and that's normally how clustering works. This might be a hard drive here, and it could be a SAN, it could be anything, even an external hard drive. It doesn't really matter. It has to be something that both can access the storage to at the same time. Again, normally that's going to be something like a SAN. And in this case, what happens is we have an active and a passive. Maybe this one's active, and it's issuing all of these addresses to both subnets all the time. This one's passive and really doing nothing. Its whole job is to listen to the heartbeat of A, which is a signal that's sent out very frequently to identify that this active node is still up. But if it goes down for some reason, then this DHCP2 no longer hears the heartbeat, and it now becomes the active node, and then it will just simply take over the database that DHCP1 had started up here and that had been working with all along. Now, this is pretty transparent. Clients usually don't even know that this failover has happened. Works out pretty well. There's only a single point of failure. Can you see what it is? Yeah, it's this right here. What if the drive were to go down? Well, then we can't get service on either one of these hosts, and our cluster fails at that point. I know there's other kinds of redundancies you can do in the SAN to make sure that storage is available, but that's, again, another configuration or another thing that you had to figure out. So now what we have with DHCP failover is we have two methods to work with, load sharing and hot standby. Let's take a look at how those. Here I've gone to DHCP2, which is where I restored the scope earlier. So this is the one that's actually active right now. It's got the leases out there. It's got all the configuration and everything like that. Over here on DHCP01, I have nothing going on. It's authorized, as you can see right here. Okay, it is authorized. However, there's no scopes or anything like that. So I want to use that one as a partner in my failover scheme. So what I'll do is I'll go to DHCP02, where I still am right here. And to make things simple, I'm just going to add DHCP01 here, so you only have a single interface to work with. Okay, so I'll add that in here, and then now there's DHCP01. Okay, so anyway, I'm going to go to DHCP02 here. I'll right-click on the scopes, and I'll choose Configure Failover. And then here it says Select All. That's because I've only got a single scope. Plus, if I had more than one, by default it says Select All anyway, but otherwise you could pick and choose which ones you want. I'm going to click on Next, and then we specify the partner server. If it doesn't appear in the list, you can simply add it quite easily, and I'm going to choose DHCP01 as the partner server. Click on Next. Then what we can do here is, look, down here at the bottom, or in the middle, it says Load Balancing Percentage. The local server, that is DHCP02, gets 50% of the load. The partner server gets 50% of the load as well, and that's how it's going to be distributed now. Also, they will both replicate the database back and forth between the two of them, so it's going to be a consistent database. That was another problem with the earlier split scopes, is because they both had their own databases respectively and might not have other things in mind, such as, well, reservations. With split scopes, I have to configure the reservation on both of those servers so that no matter which one is doling out the addresses, a specific host always gets the same reservation. Okay, so that has to be done manually. Here, I don't have to do that. I don't have to worry about that type of thing. Likewise with filters. I don't have to work with filters on both of them individually. This will also work automatically because, again, the database is going to be shared. Then I can also enable a message authentication, which is a shared secret, to make sure that I don't have any kind of a impersonating DHCP server on the network. I'm not going to do that in our case. But then I just click on Finish. It happens almost immediately here, as you can see. And now if I go up here to DHCP01 and I'll refresh the screen, we can now see that it is also issuing a scope. It also has the same leases, okay, because they're using a replicated database that they're both constantly aware of. What else did I say? Oh yeah, filters. They also both will have the same filters, as we can take a look at earlier. Man, I got to get rid of that. If you do anything, by the way, if you edit any of this, you should always do the primary. So I want to get rid of that on my primary so that I can play internet games later on tonight on my iPad. Anyway, so there we have it. Notice how I said that, by the way. Play internet games on my iPad later on tonight. I want to make sure that everyone knows I never play games during the day very often. Okay, so let's go ahead and take a look at another thing we could do. I could right-click here and choose the properties of this as well. And if I wanted to tear this whole thing down, I could go to my failover item right here, and I could just delete, the failover item that we have, the partner server. Okay, click OK and close and OK. And then if I refresh up here again, we'll see that this is going to go back to normal now, and it doesn't have, again, any of that stuff. Now, let's configure it the other way. And that was to, where's our configure failover? And that's to go ahead and work with it in the other method. And I'll just get there so you can see what I'm talking about. Okay, so we'll click on Next. And this is where I was going to talk about load balancing or hot standby. Hot standby simply means that the other server never issues addresses until my primary server fails. This is actually a good solution to have in something like a hub and spoke network. Let me just draw it out for you because I'll get a new whiteboard going here. Hub and spoke network. So I've got branch office, branch office, branch office, branch office, hub office here with a gigantic DHCP server. Okay, each one of these branch offices probably has their own DHCP servers. Okay, and I want that to be the case. But here, if I wanted something like a hot standby situation, this would be my primary, and this would be my hot standby. And it would then, if this were to fail, then my clients would be able to go across the network to this server right here. That's very often how this kind of a scenario is used. That's, again, something of an arbitrary number. 5% might be a good idea. If you were sure that any outages you experienced, like what we saw here, might just be temporary. Maybe maybe this is just down for maintenance, or we needed to add another processor or do something simple to it, and we knew it would come back in short order. Then we could just make it smaller. But if we have regular problems frequently, we might make it 10 or 20%. Again, somewhat arbitrary. We're not going to use message authentication. Then we'll click on Finish and Close. And now we can see that once again, if we go back up here and refresh everything, I think it's refreshed, there we go, then we will see that we have, again, the same leases, the same scope options, and everything else is in place. All right, folks, I had to pause recording for just a moment. I had an emergency come up, yes. My daughter sent me a frantic text message wanting me to make sure that I set the TiVo to record Gossip Girls. Thankfully, that emergency's been averted. Okay, anyway, so let's take a look at what we've got going on here. We set up the failover here, so the DHCP02 is the primary. This is the failover, hot standby server, DHCP01. And also, as I look at this, I want to go into the properties of this IP version 4, where we go back to the failover tab. And as I click on Edit, I want to show you something I didn't address initially, and there was a couple of dialog boxes there. One of those was this State Switchover interval. What is that about? Well, you see, if there's ever a communication problem between this server and the standby, then what'll come up is it'll say communication interrupted. And we'll get a message here right in this interface that will tell us that. And then it will change this dialog box here so that this button is no longer grayed out, and we could click it to indicate that the partner is down. Okay. What could also happen is this depends upon an administrator to actually get in here, see this, and to click the button. Okay. You're not always there to do that, however, and it might be the middle of the night, or you might be on vacation, who knows, whatever else. So the state switchover interval will say, hey, after 60 minutes, if we don't hear from that partner, we're just going to assume that it's down, and we're going to automatically switch over so that an administrator does not have to, get up out of bed at 3 a.m. and click the button. Now, the other part of this is the maximum client lead time. I've seen this misdocumented so many times, even in Microsoft documentation. And, who knows, maybe I'm the wrong one here. But this is what this actually is if you look at the RFC. This will take the least time that the client has, and in this case, it will add however much time I specify here, in this case, an hour. Now, why would it do that? It doesn't actually add that to the actual lease of the client. From the client side of things, maybe their lease looks like it has, 8 hours left. Well, it'll still look like it has 8 hours left. But this padding that we see here for the additional hour is communicated to my replication partner so that if there is a failover situation, it will be able to look into, let me clear all this up now, look into any address leases that it has, and I've kind of cleared this up so I only have a single one here. It'll look into this, and it will still see a relatively accurate picture of the leases there. Because otherwise what could have happened is that one of these clients might actually be missing from the lease because we didn't pad the time. And the client may actually still have that lease, but it just does not appear in the list, and it could be that a duplicate address would then be issued. So in short, the lead time there is just to ensure that we have a smooth synchronization and a smooth switchover from the primary to the hot standby. Now, the other part of this is this maximum client lead time, and boy, is this ever confusing. This is documented a number of different ways, and they all seem to disagree with one another, but I'm going to show you something here, practically speaking, that will kind of bring this to light. Okay, we're just going to prove what this is. This really should say maximum client lease time. I think it would be much clearer if they did that. Look at what we've got. We've got an hour, and remember, we originally set up a scope for only a 2-minute lease duration, which is extremely short, only for practical demonstration purposes, which I'm about to show you here. So this is the IP address on my client, .36, and then the DHCP server is 72, which is my DHCP02 server. Now, the 2-minute lease duration that I have is actually going to be kind of padded a little bit, and you can see here that it gives us, about 5 minutes for that lease duration. Let me just go ahead and IP config and renew, just to double check that, just so we can get a new IP address and configuration from our server, and then I'll do another IP config, all, and again, yep, sure enough, we see that we get just a few minutes in there. This time we got 12 minutes. So it looks like there's some kind of an offset involved in that. All right. So again, our scope duration for the lease time, 2 minutes. The actual time that we saw in this setting over here is 1 hour. Now let me just change that. Let's go back and cancel this. Just hang with me, folks, because I'm going to show you something here in a moment to kind of prove this all out. We're going to change our lease duration from 2 minutes to, let's go back to the default of 8 days. Okay. Now let's go ahead and renew everything again. I'm just going to clear the screen to clear up the clutter. Renew. And then we'll do an IP config all. Now look what we have. We have a lease duration of a little over an hour. What is that telling us? That tells us that whatever our lease duration is, it's only going to be a little bit of a padding duration plus the length of, oops, wrong location there, the length of this setting here for the maximum client lead time. All right. So in other words, the lease duration cannot be anything longer than what we see here plus our padding. And that's why we have a lease time of about a little over an hour, even though my scope is set for 8 hours. Now that's kind of weird, isn't it? Also, when we compare this to load balanced mode, we'll see a difference as well, because in load balanced mode, both DHCP servers are issuing addresses fairly equally. In other words, like 50-50%, kind of how we saw in the default settings there. The way it does that is it will take a hash calculation of the client's MAC address, and if it's in the bottom half of a certain range, then one DHCP server will issue the address. If it's in the top half of a certain range, the other server will issue the address. That's how it keeps track of how many leases it issues. That's kind of how it makes it fair or equally distributed. So you're not going to be tested on that. However, with this, nothing's going to be issued by my standby server. It's got 5% of the available address range reserved, so probably somewhere up in the, let's see, 10.10.10.240 something range, I'm guessing, because that's going to be probably in the upper 5% of the range. And that's useful because it does need to be able to both renew addresses, which it will be able to do. That's DHCP01. That's my hot standby. If this server goes down, it'll be able to renew addresses that already exist and renew those leases. And it should be able to issue new leases out of this 5% until we can figure out what the problem is with our original server. Now, if it turns out that DHCP02 is down and we don't know if it's ever coming back, then we could change to partner down, and then we could, or we can also use this state switchover interval so that after an hour it would do itself by itself automatically. And then at that point, DHCP01 will take full control of the entire scope, not just this one 5%. Now then, to simulate an outage, what I've done is I went over to DHCP02, which was my primary, and I disconnected the network card. So it's down. Now I've gone over to DHCP01, which is where you can see this interface open right now, and what I've done is I've gone to the failover tab again, and then we can see here we're in hot standby mode, the partner server is 02, but we lost contact with the partner. If I click on edit, I can also choose change to partner down. I'll just go ahead and do that for the time being. Okay, and then once I've changed that, then I'm going to go back to my client computer, which is, where is it? Right here. That's my Windows 8 computer. I'm going to clear the screen again. And now I'm going to do an IP config, renew, and we're going to see that it picks up an IP address from DHCP01 instead of 02 because that server's down. And so what do we got here? It looks like it got an IP address of 10.10.10.245. Let's do an IP config /all to double check who it got it from. Yep, sure enough, got it from 10.10.10.71. And that's my DHCP01 server, so it looks like failover worked quite nicely. You know what, we've got extra innings here. Let's see, there's 9 innings in a game, so there's 10 innings, there's 11 innings. Let's do one more inning. How about this one? All right. All right, let's take a look here at IP version 6. There's really not a whole lot to this, because remember, through stateless configuration and router advertisements, your clients can self-configure their own IP address. You don't really need IP version 6 in DHCP for that purpose. However, you may want to set server options, and that would be things such as the DNS server that you want to use, or maybe some other kind of configuration options you want. Again, you don't even really need to put in the default gateway because that will be configured as well through the router advertisement. So here what I just enter in an IP address of DNS server that I might have, and I'll try to enter in something quasi-realistic because remember with IP version 6 you can kind of just make it up. Just about. You have so many ranges of addresses. But in most organizations we'll use something like FEC0 or FED0 : I'll say 1, just to make it real simple here. And then we'll click on Add. And then we'd click OK. Now what would happen here is, if I were to go ahead and enable this by authorizing this server, so I'd right-click on it and choose Authorize, refresh the screen here, then from this point forward, anybody that receives an IP address from their stateless configuration can also receive this server option from the DHCP server. In this nugget, we addressed DHCP. We took a look at things such as how to configure a scope, how to install a DHCP server, how to make reservations, configure the various options, work with PXE Boot, because remember, you have the UDP port 67 that kind of gets in the way of things sometimes there. We took a look at the DHCP relay agents and how to authorize a DHCP server, in addition to our extra innings material relating to backing up and restoring a database and reconciling it, and also how to work with failover. Well, I hope this has been informative for you, and I'd like to thank you for viewing.